So now let's look at a special type of problem that involves reactions that have an equilibrium with a small k value. So we're interested in these types of reactions because a small k value allows us to make an assumption later on that it will make our mathematical calculations much simpler. So here, let's say I tell you I have an initial concentration of 1.0 molar of HCN, and then I also tell you that this reaction is involved in an equilibrium. I also tell you what the K value is, and what we're interested in is finding the equilibrium concentration of our two products, CN minus and H3O plus. So in this case, I know my reaction needs to go to the right to reach equilibrium because initially my concentration of CN minus and H3O plus are 0. So I know that some of my HCN must dissociate to make some of my CN minus and some of my H3O plus. The next step is to consider the equilibrium expression for this reaction. So products divided by reactants, and remember, water, because it's a liquid, does not show up in my equilibrium expression. So I know my equilibrium expression is going to be equal to my equilibrium constant, and then what I do is I take this idea and plug it into my equilibrium expression. So at equilibrium, my concentration of CN minus and concentration of H3O plus are going to be equal to X, and my concentration of HCN is going to be 1.0 minus X. And if you were to try to solve for X in this expression, you would figure out you'd have to use the quadratic equation. So we're going to use an assumption that X is going to be small compared to 1.0 in order to get around using the quadratic equation. And this assumption that X is going to be small is usually only true if the K value is relatively small. So we will be able to check if this assumption is correct. So once I assume X is small, I can get rid of that, and then I can solve for X relatively easy. I then multiply both sides by 1.0, I combine the two X's together to get X squared, and then I solve for X. And then remember, in our original equation, we said that X is going to be equal to the concentration of CN minus and the concentration of H3O plus. So once I find X, I then know that that's going to be equal to the concentration of H3O plus and the concentration of CN minus. Also remember, we know that we're dealing with a Kc here, so the units on our concentrations are going to be in molarity. So we made the assumption that our X value was small relative to 1, so we want to check and make sure that that is an appropriate assumption. So it is appropriate if X divided by the number that we compared to X times 100 is less than 5%, then that assumption is considered okay. So in this case, our X value was 2.5 times 10 to the minus fifth. We assumed X was small compared to 1. When I do this calculation, we get a value of 2.5 times 10 to the minus third, which is much less than 5%, so the assumption was okay.